Hello, good morning. It is Monday, October 15th, 2018. This is Thoughts from a Dizzy Dude. I'm your Dizzy Dude, Adam Tilted, and today I'm going to be talking about what's real, what isn't. This is a cool... Hi, Paula. Thanks for joining me this morning. How are you? Hope you're well. This is actually the wrong photograph I meant to put up here. Let me switch it real quick. This is the Butterfly Nebula. As seen from the Hubble telescope, but this is what I wanted to show behind me. This is the Crab Nebula. That's really going to be just a backdrop for my topic today, because I was thinking about how we understand the world around us and how that's different for you than it is for me. And then I was realizing that, the way we get our information about the world around us is from our senses. Then our brains interpret that information through the lens of our experience, any biases we may have, any ignorances that may prevent us from understanding. And so how I see the world and you see the world may actually literally be different. That's why we agree on things like measurements. Like, this is a centimeter, and it's a physical thing that you can actually and even still, who knows, really? I mean, if you really want to get trippy about it, who really knows? So this got me thinking, of course, about astronomy. And do me a favor, if you're liking this content, give me a share, turn on the bell. It's a lot more fun when I get to talk to you live and answer your questions as they come up. So there are colors we can't see, smells that we can't smell, sounds that we can't hear. We know this, and we're pretty smart, so we found tools to help us extend our senses. For example, we use dogs to help us find people that have been buried in rubble and earthquakes. Or we create microscopes that allow us to see things that are really small that we wouldn't be able to see otherwise. Or telescopes that allow us to see things that are really far away. Or telescopes that allow us to see wavelengths of light that we can't see. And that's what's behind me here, is an image from the NASA ESA Chandra X-ray Observatory. It is an X-ray observatory. So Hubble it has a lot of different instruments, but we primarily think of Hubble as an optical observatory. So it is detecting wavelengths of light that are similar to what the human eye can see. Chandra, on the other hand, is designed to detect X-rays, which are way outside of the spectrum of what we can see. Now, we are familiar with X-rays, and we know that they are so energetic that they can pass right through our bodies. And we've used that knowledge to advance our medical science. But X-rays can also tell us a lot about these distant objects. So I want to show you what I mean with this, just a few images from Chandra. This is what the Crab Nebula looks like in optical wavelength. Now, the colors are fake, okay, because this is going to be a composite image in just a minute. So these are not true color. Now, when I say the colors are fake, what I mean is this would all look just kind of white. In order to, you have to have a long exposure to capture this. So They use other information to add colors, but for this image, the optical light, all of it is represented in green. Okay, so this is what the Crab Nebula looks like in optical light. And this is a very well-known nebula. It's one of the closest to us and has been known to the ancients. Ancient Chinese astronomers were very aware of this nebula and paying attention to it. This is what the nebula looks like in infrared. Now, infrared are the shorter wavelengths that represent heat. So we have developed tools that allow us to see in infrared. You know, those infrared night vision goggles. So that's what the Crab Nebula looks like in infrared. In ultraviolet, which is the opposite end, so these are really long wavelengths, this is what it looks like. These are all the same object in space. We're just looking at different wavelengths of light. And then in radio waves, wow, now this is really interesting because we're seeing a lot of things happening in this nebula that you don't see just by looking at the optical data. This is what it looks like in X-ray. And suddenly a surprise is revealed. There in the center of the nebula, clearly seen in X-ray, see if you can see that. Right there in the middle, there's a jet. There's a black hole in there. And there's a jet of energized particles coming from that. Could not see that in any of those other images. There were maybe some hints that now that we've seen it, if we go back and look, we can find them. So let's put all of these images together and we see this. This is the Crab Nebula. That is amazing. Now, of course, this is not what we would see if we were in a spaceship and we went up to the Crab Nebula, because this is information that our senses cannot detect, but they're there. The wavelengths, the X-rays, the radio waves, the magnetic fields, they're there, and they're all around us as well. And that to me is fascinating. Not only just on this particular example or, seeing this, but also in a more abstract way. Because when we look around at our environments, remember that we don't see everything. We don't smell everything. We don't hear everything. There are things that are happening around us that are beyond our capability to detect. And those may have an impact on us. So be sensitive to that. Some people are more sensitive to these invisible factors than others. Air pressure is one. In fact, you can't really see it. You can kind of feel it, but it has a huge impact on me. And speaking of, let me just show you this. I don't know how this is going to look on the green screen, but we'll see. See that pressure? It's about to go nuts here. Crazy weather's coming our way. I'm glad that I was able to get this in. Anyway, I'm going to be talking more about Chandra X-ray telescope on Orbit at a Tilt tomorrow night at 7 p.m. Central Time. Okay? Tomorrow night, 7 p.m. Central Time, the Chandra X-ray telescope. Join me then. Have a fantastic day.